these 5 things which are very important. The first and the foremost, the rate of change. What do you mean by rate of change? What is an increasing and decreasing function? Okay, when we say the function is increasing at this point to this point, or the interval it is increasing, then we'll talk about, we know about tangents, we know about normals. Okay, what is the equation of a tangent for any kind of curve? So we'll find out, figure it out. Then we'll learn about approximation. Always we can't find out the exact value. So can we approximate it to some nearest value? How to do that? Using the derivative part. And then the most important, maximum minimum. Now one thing which you need as a prerequisite for this is the basic area volume formula. So everybody till 10th they have done the area volume formula, area of sphere, cone, cylinder and all that. So that area and volume you need to know so that you can apply for the maxima and minima kind of questions. Okay, which area will be for what value of length, the area will be maximum or minimum. So these kinds of questions also will have. So, and one most important and the very most important thing is, a lot of second PU questions are important. Now, since they are giving you a second PU question, so don't understand that we have to solve everything fully. Okay, we don't have to solve everything fully. We need to find a way or a method to solve it in the least possible time. And here in our case, the situation is we have to solve in less than 30 seconds. Okay, so that is our main target. But a lot of similar questions from the second PU, you'll be able to say it in the KCET part. But there in the second PU part, what we had to do, we had to write everything step by step. You have to solve it. Here you have to find a way, find a method so that you can approach to the answer in less than 30 seconds. That's our main aim of this video and the PYQ series. Now the PYQ we might be uploading separately also, or if we are able to upload it together, we'll try to put it up, because we are having some issues with the software rendering the whole editing process. So be there with us. We are trying our level best to give you the best what we can. Okay, so this whole topic is very simple. Okay, first thing to understand and to start any chapter is you need to understand the chapter is very simple. What happens, psychology plays a very important role. Understand this small story. When we were in class 10th, so when we used to read that chapter, what happens, the 10th seemed to be the class 10th syllabus and everything, the chapters, the questions, it seems to be very difficult. Okay, the moment we go to class 11th, even though we have done bad in 10th, let's say, okay, if we have done good, well and good, even though we have done bad in the test, what happens now, since we are in 11th, the 10th seem what? Very, very, very simple. The moment we see any student or any of your younger brothers solving a 10th question, you say, oh, that is so simple. But when we were there in that point of time, correct, what happened was, we used to think, oh, we are in 10th, it was supposed to be hard. Okay, the mind situation is, we think that, okay, this is hard. The moment you start a chapter by thinking that this is not hard, this is the simplest chapter that I'm gonna study, this is the simplest chapter I'm gonna study, okay, and I'll do best in that. So the moment brain hears this, okay, this is the simplest chapter, it will be easy, it starts taking it easily. Even if the concepts become complex, the brain will be able to take it easily. So understand, it is definitely easy, don't worry about that, but still saying something that even if it is difficult, you approach that thing with the mind that it is easy and I'll be able to solve it, you'll be able to solve in 99% of the cases. Okay, so don't worry about that. That chapter is really very easy, and you have to say it also before starting it. It is damn easy, and I'll make it more easy for you so that you don't have a single doubt, a single difficulty in solving the PYQs properly in less than 30 seconds. So first, what you're going to study will be the rate of change. Now, basically, the moment we ask ourselves, what is rate of change of quantity? So basically, rate of change means change is there, something is changing, correct? Now, but what rate it is changing? So we want to understand that at what rate something is changing, then we talk about the rate of change. So, and that we denote simply by dy by dx. The rate of change in y with respect to the rate of change in x. So rate of change of y with respect to x. That's simple. Okay. Let's say you have a balloon. You are filling up the air in it. Okay. The moment you are filling up the air, what is happening? Volume is changing with respect to 1 with time, correct? 1 with the radius also, because if volume expands, what will happen? Your radius will also expand, correct? So the moment the more air is going in, the more radius, the more bigger it will be. So we can find the rate of change of volume with respect to radius also. Okay, so this is basically means the rate of change of anything. Something is changing, but at what rate? Rate here generally means how fast or slow. Okay, rate here generally means what? How fast or slow that commodity is changing with respect to another commodity. So the moment we say dx by dt, we already read about velocity. So rate of change of displacement with respect to time, how fast the displacement is changing with respect to the time what you have taken. Okay, so that is velocity. So a lot of our activities is based on the rate of change. The moment somebody accelerates a bike, okay, so what happened? There is also a rate of change in terms of velocity, dv by dt. Okay, acceleration is nothing but what? dv by dt, rate of change of velocity, how fast you are accelerating or decelerating. It can be positive also, it can be negative also, it can be zero. You're like somebody is driving, okay, and you're driving with some older people and they're not speeding up. Sometimes that happens. So what happens? My diagram is pretty bad, okay, so don't worry about the diagrams. So they're not accelerating, they're like going with a constant velocity, like going slow. Okay, let's say 20. Okay, so constant velocity 20. So there is no rate of change with respect to time in the velocity at least. Okay, so that is basically in rate of change we'll study. Nothing more than that, nothing less. Very simple. Understanding of rate is what? Change we are studying, but we want to know, now we want to quantify it. We want to put a number to that change. Okay, we want to say that how fast it is changing, the value of the change. Okay, we know change is happening. The moment we talk about the volume, we know the volume is increasing, but how fast and with respect to what we are telling. We are telling that volume change 10 times, but with respect to what? In one area, in 1 hour, or in 10 hours, or in 50 hours, how much? And with respect to what? The volume became 10 times with respect to what? The radius with respect to. So basically here we are doing rate of change of one quantity with respect to another. So when we say dy by dx, it simply means rate of change of y with respect to x. That's it. So pretty simple, nothing was there. To sum up everything, rate of change of quantity is nothing but how fast something is changing or how slow something is changing with respect to another quantity. Okay. Now coming to the next part that we have is tangent and normal. You need to understand what a tangent is. Now basically what a tangent is, I already told you in the previous continuity and differentiability video what a tangent is, but still I'll again see. We have a curve like this, correct, and you have taken a point P. So at this point when you draw a line which is just touching the P at one point, so this is the tangent. That's it. Clear? Now for any curve y is equal to fx, a line touching y is equal to fx at just this point x1 y1 is the tangent to the curve at x1 y1. Clear? At that point. Okay. Now old stuff like which we need to, like the first PU stuff, the slope point form, a point slope form. Basically whenever we have one point we have and we have one slope, okay, and we have the slope. So how to write the equation of a line when we have, let's say, 1 point x1 y1 and we have the slope of this line, that is let's say m. So then we write as y minus y1, this we have taken what is it, some any arbitrary y minus y1 or the general is equal to m times of the slope into x minus x1. So because basically any random point, if you take it x comma y, so what will happen? The slope between these 2 points will be equal to the m part, correct? And how do you find slope? y2 minus y1, so y minus y1 by x minus x1 equal to m. So you just substitute this whole thing that side. That's it, you got this formula. Okay. Now here for this chapter in KCET part, this part is important. Now we have done the slope of the tangent at this point is given by just nothing but dy by dx. If I want to find the slope of this line, correct, that is m, so that is nothing but dy by dx. Now I am finding the slope at which point? Point P. So this is important, I am finding at x1 y1. So substitute the value, you will get the slope at that point, and that will be the slope of that tangent at that point. That's it. Now we already know the tangent. We already know the slope of the tangent. We already know the slope of the tangent, that is dy by dx instead of m at x1 y1. So slope we know, and that is m, okay, for this line. And we already know 1 point. So can we apply this formula? Correct. So we'll take just one random point x comma y. We'll use the point form, these two. So y minus y1 by x minus x1. So I got a slope from these 2 points. And that is equal to this slope, because slope of the line remains same for all, that is equal to m, and that is equal to what? Dy by dx at x1 y1. That's it. Clear? And for the whole line, the slope remains same. So you can use it. Okay. The slope which I got by these 2 points, okay, let's say x and p, and that is what you say. This was the formula, y minus y1 by x minus x1, and that is equal to the slope, and that is m, and that is equal to dy by dx at x1 y1. So that is the equation of the tangent which we can find at this point x1 y1. Pretty simple. Now what we did, we took one, again I'm recapping it, we took one, what do you say, general point xy, we found out the slope, this one, okay, which formula, y minus y1, slope form, y minus change in y by change in x by x minus x1, and that is equal to the slope, and slope is equal to what, student? Dy by dx. Just now we said that slope of the tangent is nothing but dy by dx at that point. That's it. Clear? Done this equation. Now I'll say, sir, what about the normal? See, you have already drawn a tangent line which is touching this point P at one point. Now draw a line perpendicular to that. That's it. Now you remember in first PU, in the straight lines part, we learned one formula. The slope of any two perpendicular lines, slope of one line into the slope of the another perpendicular line is equal to what? Their product is equal to what? Minus 1. So slope of the normal into slope of tangent is equal to what? Minus 1. So slope of the normal will be equal to what? Minus 1 times the slope of the tangent. So minus 1 times the dy by dx at x1 y1. Correct. So equation of normal will be same thing, just where we were putting m in case of the slope of tangent, here we'll put minus 1 by m, and that is equal to dy by dx at x1 y1. That's it. So nothing changed. Only thing is, in the case of normal, this part earlier we were substituting in here, we were substituting this f dash x or the dy by dx at x1 y1. Now what we substitute? Minus 1 times of dy by dx at x1 y1. Clear? That's it. If anybody has any doubt, you can take a screenshot, put on the timestamp, and you can ask questions. And we are coming live very soon, so you can ask questions there, then and there also. Now, two cases we have of the slope. What happens is, at some points when the slope is perpendicular to the x-axis or parallel to the y-axis, same thing, anything you say. So perpendicular to the x-axis and parallel to the y-axis, here tan theta is what? 90 degree. We know that tan theta 90 degree is not defined. Okay. So in that case, the equation of the tangent will be what? Directly x is equal to what? The equation of this line is equal to what? X equal to x1. Now, and when the slope is, what do you say, 0 degree. So in that case scenario, what? It is just a line which is parallel to x-axis. So directly I can write that equation of that line is equal to what? Y is equal to y1. So in both the cases, we should know the moment they say that the tangent is parallel to y-axis or perpendicular to x-axis, directly the equation of tangent is x equal to x1, and the other case it is equal to y is equal to y1. That's it. So pretty simple. Okay. Now, so we are done with tangents and normals, almost everything. One more formula, sometimes we use it, sometimes KCET has also asked angle between two curves. Now what they did is, they gave you one curve, they gave you another curve. Now how to find the angle? What you do? Draw two tangents on them. The angle between the tangents is equal to nothing but the angle between the what? Two curves. The angle between the two curves is nothing but angle between the tangents. Angle between two curves is equal to the angle between their tangents. Angle between their tangents. Okay. And we already know how to find the angle between two lines. We're using the slope method. So this is m1 is the slope of one line, m2 is the slope of another line. So the angle tan theta between them is equal to mod of m1 minus m2 by 1 plus m1 m2. So this is the formula we'll be using. Now one very important concept, student, orthogonality. They'll say check whether the two curves are orthogonal or not. A lot of students, the moment they'll listen to this name, orthogonal, sir, we don't know it, sir. Orthogonal means something very complex. Nothing. If the curves are making an angle of 90 degree, they're orthogonal. Correct. Let's say one curve is like this and one curve is like this, one is like this, one is like this. If the angle between them is 90 degree like this, they're orthogonal to each other. What they are? Orthogonal. They are orthogonal. Okay. What is the condition of orthogonality? The slope of first into the slope of second, product of them is equal to minus 1. That's it. Or the angle between them is pi by 2. So done. Once you get that, that is done. Clear? Now, before starting the increasing decreasing, we learned about the two important concepts. One, the rate of change. Second, the tangent and the normal part. So if any doubt, you have the WhatsApp. You have the WhatsApp link. Okay, you can put your doubts on the WhatsApp. You can put your doubts on the Telegram channel. You can put it on the comment section, and fourth, you can also put it on the website. Okay, every link is given in the description. You can go through and you can put it up. Do make a short notes. I give a lot of emphasis on making the short notes, because last 1 week the revision will be mostly done properly by students who have done the short notes. Students who haven't given the importance of making the short notes now, they'll regret a lot in the later section. Because what happens when we want to revise the whole of the maths 11th and 12th in one day, what comes handy? The short notes. They'll say, sir, I'll just borrow it from someone. Others short notes, the way they have written something, they have written, oh, orthogonality, they've written just a perpendicular. But you might not understand. Orthogonality, they've written m1 into m2 is equal to -1. You might not remember, because in that notes, they haven't written m1 into m2 is equal to what? The slope of these two lines, m1 into m2 is equal to what? -1. So what will happen? Your own notes helps you the best. No other notes can help you. Okay, so make your own notes. That is the most helpful thing that you can do, and the revision will become perfect. Students who score above 50 out of 60 marks in, not the 50% in KCT, out of 60 marks in maths, who score above 50 plus, they all make short notes. Okay, and they revise it multiple times, 3 to 4 times, 5 times, 6 times. The more you revise, the more formulas will be linked like this. Okay, or if the moment somebody asks or gives a question, oh, this formula, this, it was in this short notes, I revised it like 6 times, 7 times, so I remember. Done. Directly they'll put the answer. And what happens? A lot of students, they complain, sir, we're not able to solve the whole question in less than 30 seconds. What happens? What is our issue, sir? We are working hard. Students, you are working hard, but you're not working smart. Understand, students, working smart means you need to what? Relate things, and you can relate only if things are in a ordered and sequenced manner. So when you have the short notes, you can relate these short notes to this. Okay, when it becomes perpendicular, okay, it is called orthogonal also in the, I read in the AOD section. Clear? And in the straight lines, I understood the condition for orthogonality is that the product of the two lines should be equal to the slope of the product of two lines, it should be equal to -1. So you can relate stuff, okay, only when you have proper notes. Okay, so give a lot of importance on making short notes. You won't regret. Last 1 week we'll be revising everything. There your short notes will be your best friend. Okay, it will be more than your best friend. Okay, trust me. Now, coming to the next part, the increasing and decreasing function. See, the name suggests one is increasing. Means increasing what? If you change one thing, the other will increase. See, when we write y is equal to fx, if I increase, okay, it's vanished, okay, don't worry. When we write y is equal to fx, when you increase this x, this y should increase. So it's a direct proportion, correct? We remember this direct thing, okay, in proportionality, direct proportion and indirect, okay, and inverse proportion. So direct means what? If one thing increases, the other has to increase, correct? When you go to the market, if you buy more product, you have to pay more, correct? So product, that is their product, and the cost goes like that. The more product you buy, the more cost will be of that. Okay, now, so the moment we understand by increasing function, the moment we say what is increasing function means, the moment I increase my x, okay, if you see, the moment I increase my x, my y has to increase. That's it. What is difficult in this? Nothing, correct? So we can put values and we can check. If they say not always we have to, what is a differentiate, we can do that also. Not always we have to differentiate and get, we can put values and also check. If I'm increasing the value of x and I'm getting a value increase in y, it means increasing function, correct? Now, so next, a word very important, mark it down with a different color, okay? Mark it down or highlight it. A lot of students, they don't highlight this word, strictly, okay? So strictly, sir, why you have highlighted? Strictly means it is never, what you say? What? Constant, always increasing. Strictly means always increasing, okay? When a function is always increasing, okay, so that case it is known as strictly increasing. So in case of strictly increasing, whatever values of x, the moment you increase a light also, means by smaller amount, it will increase, it will increase, it will never be constant. Here in this case, you will understand more better with the second graph. See here, from here to here it increased, but then the increase was not proper, it was almost constant. I increased the value from here to here, I increased the x value, but y remained what? Same only. So not strictly increasing. This function, see, a bit change in x, bit change in y, change in x, change in y, increase in x, increase in y, increase in x, increase in y. Here I got increase in x, till here increase in x, increase in y. Okay, here increase in x but no increase in y. So when people or students they study just hard work, not along with the smart work, what will happen? Starting wise the marks will increase, later it becomes stagnant. You're increasing your efforts but it's not going. Why? Because you need to understand how to put the efforts, okay, and it should be in the right direction. Okay, now let's understand with a very small story, just 1 minute it will take. Two brothers were there, okay, and they went for the every day they used to, like, a lot of people would have heard this story, correct? They always used to go and cut trees, okay, they were like woodcutters, they used to go and cut trees, okay. Now what was happening is, this brother, let's say as x, this brother, mathematically we are talking about a story, so let's name them as x and y instead of names, okay. So one was x, the other was y. So x every day used to bring what? More number of trees than y, correct? But what happened? Y was always very depressed, like what do you say, I do very hard work but still, what do you say, my brother x always brings more wood than me. Okay, so what is the problem that I'm having? So one day they said, okay, let's make all the variables constant. In maths we say, no, let's make all the other parts, all the other variables constant. Okay, so what they said is, we'll start like morning 6 a.m. okay, and we'll cut till evening 6 p.m. So 12 hours will give, morning 6 a.m. to 6 p.m. will give 12 hours each, and we'll see who is cutting more. So since now every variable is same, because both are working for the same number of hours and both have their own equipments, okay, and the same day, so now every other variable is same. So if one is doing hard work, then that person has to bring more, what is a wood, correct? So they did that, they went. That day what happened is, again x brought more number of wood than y. Now y became really very depressed. He asked x, how did you brought more number of wood than me today also, when I kept the other variables same? Now x smiled and then he said a very simple thing, that what happened is, 6 hours I sharpened my axe, the equipment, okay, the formulas for you all students, okay, 6 hours I sharpened my axe, okay, the weapon by which they were cutting the trees, and that helped me to cut the trees so fast. It was so what do you say, sharp, that whatever the amount of time I was taking to cut down what do you say, one tree, that was what do you say, 1/3, or let's say 1/5 of the time what you were taking. Okay, so even if you had have worked for 30 hours, I could have done the same work in like 6 hours, correct? So then that day he understood, why understood, that we need to be a bit smart also. So students, there is 2 to 3 important things that you need to understand from here. So first thing, your formulas, your short notes are like your what? Your weapons, okay, for the exam. So the more better they are, the more better chances you have for becoming the best or scoring the best marks in the exam. So one and foremost, the most important thing, okay, because when you are approaching the questions, if you remember each and every formula and it is linked in your brain, you can directly apply even the tough JE questions of advance also. KCT is nothing else, nothing in that. So and KCT also, okay, it's not like you can apply to any exams and you can crack it easily. That is the first and foremost thing. Second thing is, it makes you achieve, what do you say, a lot of productivity in less amount of time. Okay, so that these two, so that you have some time for yourself also. It's not like you should always just open the book and keep sitting and keep studying. Okay, you have a time where you have a life, correct, where you want to do something where with you, what is your passion, like let's say singing, dancing, whatever you want to do. Okay, so that's for the story part. Let's come to the topic. Okay, now, but very important. So what we are talking about, strictly increasing means always increasing. The moment you change a bit of x, there will always be a change in y. Okay, so that is strictly increasing. Just increasing means it will increase, some parts it may not. Okay, it won't decrease but it will be constant or like a very little. So in that case it is just increasing function. Now how do we understand with the dy by dx part? We'll check it. Okay, now, so here in case of strictly increasing, the moment you increase x, you came to x2, you increased x, x2 is like greater than x1, so the moment y2 will be greater than y1. In case of this, it can be constant, y2 can be equal to y1, though you have increased x but your y value didn't change. Okay, so that is known as just increasing. Clear? Now, coming to the next part, decreasing. So same concept what we have learned in increasing, will apply in decreasing in the other way. So decreasing means what? If x increases, y is equal to f of x. If x increases, y has to decrease. Correct? If x increases, you can understand like this. If you work hard, correct, then the scolding from your parents, okay, and if you do good in your exams, the scolding from your parents, what? It decreases. Correct? So directly you can take it like that also. So if x increases, y decreases. Okay? So see, if you are increasing the value of x, y is decreasing. Correct? Y is decreasing. Now we'll say strictly increasing means always decrease. Just decreasing means it can be constant also. Same concept. Okay? Now let's understand this whole thing, increasing, decreasing, in terms of derivative form. What do you mean by increasing, decreasing? We understood with the terms of x, change in values of x. Now we'll understand in terms of dy by dx, or the slope form. See, if you see this graph, okay, so this is increasing, correct? The moment you increase a bit value of x, you get an increase in y. How is the slope? Just take any point, draw a tangent. You see the tangent is going up, the tan theta is positive, correct? If you take a more bigger point, the tangent, this value is increasing. So what you can see, the dy by dx is what? Greater than 0, positive, always, correct? Now it is becoming 0 at this threshold, correct? Let's see, here f dash x is what? 0. So because here the slope is positive, here again it is negative, so it has to change somewhere. Okay, so this is changing here at this point C1. We'll talk about these C1s. The C1s are nothing but the points where the dy by dx is 0, and these points are known as critical points. We'll understand what are critical points. Critical points are nothing but where f dash x is doing a change, and at that change point it is becoming 0. See, whenever I'm like here f dash x is positive, correct, and here f dash x is negative. So it has to go, whenever a positive value is going to the negative side, it has to always cross 0. Or a negative value, if you see the number line, has what you say, going from negative to positive, it has to come first become 0 and then go, correct? So that's the same thing. So whenever a function dy by dx is greater than 0, we say it is increasing function. If it is equal to 0, then that are the points of what? Critical points. Again, dy by dx is less than 0, so decreasing, that's it. Again here it is what? Equal to 0, so critical point. Again it is increasing because dy by dx is positive, that's it, done. So what are critical points? The critical points where f dash x is equal to 0 or f dash c is equal to 0, where the derivative is 0, that is known as the critical points. Critical points are what? Where f dash x is equal to 0. So these are known as critical points wherever for these points. So at these points the graph just changes. Okay, it changes the sign, the derivative changes the sign, sorry, the graph changes, the derivatives changes the sign, or you can say the dy by dx, the slope of the derivative changes. Here the slope is positive, here the slope is negative. Okay, now let's talk about maxima and minima. Okay, or we'll do it in the first derivative test, don't worry. Here you got the concept of increasing, decreasing. Increasing means what? The derivative has to be positive. Decreasing means what? The derivative has to be negative. Clear? That much if you understood, this whole thing is done. Okay, so we understood the concept of increasing, decreasing, we understood the concept of rate of change, and we understood the concept of tangent normal. So out of the 5 most important things, 3 is done. So let's see the 4th and 5th. The 4th one is approximation. So basically in approximation, again we'll not go much in detail. Again, let's say we have y as a function of x. Okay, now the moment you change a bit in x, there will be a change in bit of y. So now always it is not very easy to find out that small change. Okay, so we approximate it to how much value the change is happening, and that is given by this formula. Correct? So delta y or dy is equal to change, very small change in y, is equal to derivative dy by dx into delta x. That is the formula. So we'll be using this formula. Now these 3 things, I think so you remember from the physics first chapter, second chapter, I think. Absolute error, relative error means change in error by error, original error, and percentage error, just multiply with 100. Okay, this thing we have done in physics, still I have given you. Now we'll see and understand this approximation. How do we solve the approximation? By using a question. Okay, understand it. Let's say we already know root 36 is how much? Everybody will shout, sir, 6. What if I say, what about root 36.6? You'll say, sir, it is 6, correct. And very close to this value 6. Like let's say somebody will say, sir, 6.1, somebody will say, sir, 6.2, somebody will say, sir, 6.3, somebody will say, sir, 6.002 or something like that. Very close, 6.25, 6. What do you say? 56, 6.96, okay. So what exactly can we approximate this value and get by using any formula or something and get an approximate answer to this root under of 36.6. Now what you see, if I take a function y is equal to root x, okay, so my x is equal to what? 36, and my change in x is what? 0.6, correct. So delta y, change in y will be equal to what? The original, what do you say, the new value, x plus delta x minus root x, correct. That is equal to delta y is nothing but what? Root of 36.6 if I find it out, minus root 36, then I'll get the change, correct. So root y can be written as what? If I, this value, if I know, this value is what? Root 36 is what? 6. So if I send that side, so root y plus 6 is equal to what? Root of 36.6. So now just what is it? I need to find what is delta y. So delta y or dy is given by the formula dy by dx of that function. Okay, how fast derivative of the change into the change part. Okay, so it's just like a, what do you say, unitary method. If I know the rate of change of this much, okay, of 1 unit, and then if I know how much unit is change, how much for how much unit I need, so I can find it out. Okay, we do in what do you say, surface density on all that kind of question. So that is the similar concept we're trying to pull here. So I already know what is the dy by dx. So y is equal to root x I know. So y dash or derivative of y or dy by dx is equal to 1 by 2 root x, correct. So I'll substitute that. And delta x is what? I already know, 0.6. In this 1 by 2 root x, put the value 2 root of 36. So what I'll get? 1 by 2 into 6. So that is equal to 1 by 12. So 1 by 12 into 0.6. So 6 ones are 6 twos are. So what I'm getting? What is a 0.1 by 2? So if I remove this, what I'll get? 1 by 20. So that is equal to 0.05. Everybody knows how to differentiate 1 by 20, no? Correct. So what? 0, 0, 100, 5. Correct. Done. So what is the change? Delta y, this much. So we already wrote delta y is equal to what? Root under of what do you say, or 6 plus, sorry, root under of 36.6 is nothing but 6 plus delta y, and delta y we found it at as 0.05. So this is equal to 6.05. That's it. So how simple it is. Okay, so we just need to remember this formula, that dy, change in y, is equal to dy by dx into delta x. That's it. Okay, maxima and minima. So just now we'll be using a bit of concept of increasing decreasing also. Okay, now now in maxima and minima, if you see, when we get a maxima, maxima means like a mountain, maxima means an upward mountain, you can understand. So here slope is increasing first. See, slope is increasing, the dy by dx is positive. 1 point it will get 0. Okay, because see, just now again remember the number line, it will become very easy. So whenever you are going from the positive value to negative, you have to cross the 0 boundary, correct. So at this point it is 0. So and then after that it is decreasing. So whenever the slope is first positive and then it becomes 0 and then negative, it is the point where we are having a maxima. We say local maxima because in a function when it has more than one maxima, don't get confused. So this is one maxima, this is maxima, this is maxima. So we call it as the one biggest value as global, the other smallest one as a local one. Okay, so done. So what is maxima? When the slope is first increasing, constant, and then decreasing, then we get a maxima. Okay, at this point when it has become 0, and this point is known as the critical point. Okay, now whenever it is going from decreasing, negative value, okay, negative value 0 and then to positive, so what we get here? A minima. Okay, it's like an upward parabola like this. Okay, or a V you can say. Slope is negative, it becomes 0 and goes to positive. So that time, that case, we get a minima. Clear? That case we get a minima. Now there will be some points where the function f dash x does not change sign. Okay, that point is known as point of inflection. If you see like a y is equal to x cube, here also positive, but here it becomes 0, again positive. So these points are known as POI, point of inflection. There is no change. Okay, now again let's recap. The first derivative tells us that you just differentiate is the first derivative tells us that you just differentiate one time. So what will happen? You get, if the slope is first positive, then it becomes 0 and then it goes to negative, means at this point you have a maxima. Correct? Clear? Now if it says that if you are having a negative first and then 0 and then positive, okay, so in that case it is having a point of minima at which point? Where f dash x is greater than equal to 0. See, the slope is negative, here it becomes 0. So at this point we have minima. Don't get confused, okay? So at this point we have the minima and the slope goes up, okay? You can remember this downward v, upward v, okay? Slope is negative, slope negative, it becomes 0 and then becomes positive. Slope is what? First, so this point is what? Minima. Slope is first positive, this point first is positive, becomes 0 and then becomes negative. So what is it? Maxima. Clear? Now, that was the first derivative test, okay? Now what is critical point? Critical point is a point where f dash is 0 or sometimes it can be not defined also. Endpoints are never critical points, very important, okay? These endpoints can never be your critical point. Now understand. Slope is positive, correct. The slope here is positive, here it becomes 0, correct? And then again, what? Positive. So this point is what? Point of inflection. This point is what? Point of, so you'll say, sir, f dash x is 0. Yeah, 0 it is. But the derivative is not changing, student, okay? Derivative, we get maxima and minima whenever the derivative is changing from negative to positive, okay, or from positive to negative. So in that case, whenever it is changing from positive to negative, positive and then negative. So what will happen? That time you get a maxima. Whenever it is going from negative to positive, we have a minima. Clear? So this point it is just positive to positive. Though it is 0 here, so positive to positive, POI. Point of inflection. Okay, that's it. Point of inflection. You can understand by this. Positive, again positive, but at this point it is 0. Okay, don't get confused. Okay, again here, see the slope is positive, then negative. What is it? What? Upward V or a downward V. Okay, so upward arrow or downward arrow you can say. So if it is a downward arrow like this, okay, then it is a maxima, and then upward mountain like this, then it is a minima. Now sometimes the turn is sharp, so that time directly, sir, slope here is positive and here is negative, sir, so this point has to be what a maxima, illa you'll get a 0 and come back, okay, and you won't be happy about that. So in that case it is not defined. Dy by dx, again read that continuity and differentiability part where we told you that whenever there is a sharp turn, the derivative is not defined. So f dash x is not defined, so no maxima, no minima. Okay, clear? Same thing I have done with a bigger graph. Derivative slope is positive, 0 and then going to negative. So this point is what? Point of local maxima. Again negative, then what? Positive. So slope of local minima. Okay, positive and then graph not defined. Sudden turn. Sudden turn in life means something happened. Okay, so that point means non-differentiability is there. Again sudden turn. So we say it is non-differentiable at this point. So we can't comment on maxima or minima. Okay, clear everybody? I think so. One part last, the second derivative test. In second derivative test, what we do? First, we differentiate 1, get 0, and then do the double derivative at that point. Okay, and we check if the double derivative at that point is 0, then we say it is maxima. First derivative we got 0 at that point. We did double derivative, it is positive. Okay, greater than 0, so we say it is minima. Ulta, if it is don't say ulta, say it like opposite. So if it is greater than 0, minima. If it is less than 0, maxima. Okay, and if both 0, then the test fails. First derivative is also 0, second derivative is also 0 at that point, then the test fails. Okay, now we'll be seeing it how to apply in the KCET questions in the PYQ section. Till then, the concept and the formulas, everything what you need to solve the EOD, I have given you very properly, very thoroughly. Okay, I don't think so anything is left. Go through it properly, watch it twice, write down your short notes. You'll be done with this chapter. Okay, thank you.